Hi, I am Dr. Thangakasi Rajan, Associate Professor, Department of Mechanical Engineering. Today we are going to see a topic: 3 invariant reactions occurred in iron carbon equilibrium diagram. So this is one of the very important concept in engineering, materials and metallurgy. Let me see what is iron and iron carbon equilibrium diagram, followed by why it is so important for an industry. Then we have seen the iron and iron carbon equilibrium diagram, followed by what are all the invariant reactions occurred in the diagram. Before I get into the diagram, first of all, as a mechanical engineer, we must know two things, that is the material which extensively used by industry. So those two materials are called steel and cast iron. These two materials are very important materials. Let us see an application of steel. So in steel we have low carbon steel, medium carbon steel, high carbon steel and alloy carbon steel, depending on the percentage of carbon content in iron. So this steel has very vast application in structural elements. The structural elements may be a beams, the structural element may be a machine bed, so many structural things are there. So in all the materials we are using steel, and also if we consider the shaft, axles, railway wheels and machinery parts, we are using medium carbon steel. Similarly, high carbon steels are extensively used as cutting tools, especially in chisels, drills, springs, and alloy steels, that is it is mixed with chromium and other. So we can get stainless steel, tool steel. So those steels are extensively used for specific properties. Example, surgical instruments, corrosion resistance, tools and dies. These are all some of the important applications of steel and cast iron. Let me see what are all the applications of cast iron. If we take the cast irons are extensively used as engine blocks, cylinder heads, then in rolling machines, as especially for wear resistant, it is extensively used. See, cast iron has a very good compressive strength, compressive property. And similarly in automobile structures, automobile components, pressure pipes, crankshafts, gears, in all the places we are using cast iron. Okay. Now what is the connection between these two materials and iron carbon equilibrium diagram? In all the places we have certain classification in steel, certain classification in cast iron. So depending on the percentage addition of carbon, it forms different property. Now let me see why this iron and iron carbon is so important. First of all, from this iron and iron carbon diagram, I can find the different phases of the material at different temperature. See, when the temperature changes, when the composition changes, what are all the various phases? So this information we got from iron and iron carbon equilibrium diagram. Next, it also helps to predict the microstructure. As a mechanical engineer, we should know the change in microstructure of a particular material changes the mechanical property. This microstructure influences the mechanical property. This information also we obtain from the iron and iron carbon equilibrium diagram. So based on these above two properties, as a design engineer, I can able to select the appropriate material for a particular product. This is very important. And next, as a production or manufacturing engineer, when the information obtained from the iron and iron carbon diagram helps the production and mechanical manufacturing engineers what kind of heat treatment does the product required. So, he can also able to derive the solution. So, last it links the composition, temperature and microstructure. Hence, this iron and iron carbon diagram is very important. Let me see the iron and iron carbon equilibrium diagram. So, this diagram shows the iron and iron carbon equilibrium diagram. The x axis represents the percentage addition of carbon content. The y axis, that is the vertical axis, represents the temperature. So, left side it indicates the temperature in Fahrenheit and right side it indicates the temperature in degree centigrade. First of all, very important and foremost thing is up to 2% addition, we call it as steel. So, this is very important. So, when the carbon addition up to 2% in iron, it is, we call it as steel. Similarly, beyond 2% we call it as cast iron. Here I have marked the percentage addition up to 6.7%. Beyond 6.7%, there is no significant effect on the iron and iron carbon diagram. So, hence the iron and iron carbon diagram derives the value for the percentage addition in iron from 0 to 6.7%. So, this is very important, and here so many things are marked. The first one we call it as pearlite, ferrite, austenite. Similarly, here pearlite and carbide, pearlite and cementite, all we call it as microstructure. So, these are called microstructures, and here you have 3 values, 1, 2 and 3. These 3 values are called eutectic, eutectoid and peritectic reactions happened in the iron and iron carbon equilibrium diagram. This is the 3 reactions we are going to see in the next slide. Okay. So, the same iron and iron carbon I just shown in a enlarged way. So, here I have marked 3 points, one is A, B and C. You please make a note of it, A, B, C, 3 points I have marked. The point A is called invariant eutectic point. The point B we call it as invariant point, eutectoid point. The point C we call it as invariant point, peritectic point. Let us see what is invariant point. An invariant point is a point that exists in the iron and iron carbon equilibrium diagram only for a particular composition and for a particular temperature. You cannot find the similar type of point in any of the composition or any of the at different temperature. Similar, that is why it is called invariant point. So, exactly at the point A, that is approximately 4.3% addition and at a temperature of around 1148 degree centigrade, you are having the eutectic point. So, in the eutectic point you have a liquid phase, that liquid phase is converted into 2 solid phases. This gamma we call it as austenite state, solid state, and this is also a solid state. And similarly, at 0.76% carbon addition, at 0.76 carbon addition, we have the point B, that we call it as eutectoid point. So, in the eutectoid point, a solid, that is austenite solid, is converted into 2 solid, that 2 solid is called pearlite and ledubarite and cementite. So, alpha plus Fe3C. So, these are the two, that is a solid is converted into two solids. And this is the third point, peritectic point, where you have a delta solid phase and you have the liquid phase, those two are converted into solid point state. So, when you mark the percentage of the particular point, here you have 0.18. So, approximately 0.18 percentage carbon content, 0.18 percentage is called peritectic. So, this we call it as peritectic point, and here B up to carbon addition C equal to 0.76 is called eutectoid point, and similarly point A 4.3 percentage we call it as eutectic point. So, the corresponding temperature of peritectic is 1493 degree centigrade. The corresponding temperature for eutectoid point is 727 degree centigrade. Similarly, for the point for the temperature 1148 we have point A, eutectic point. So, these are all the three invariant reactions occurred in the iron and iron carbon equilibrium diagram. Now, I am going to sum up the important highlighted points of this reaction, and you please make the. So, here you have left side region and you have right side region. Similarly, for this point also you have left side region and right side region. So, here the left side region and right side region we call it as hypo and hyper eutectoid. So, that we see here. So, okay. So, here we have hypoeutectoid and hypereutectoid. So, what do you mean by hypoeutectoid? Means left side point. In the previous side I have marked a portion on the left side, that we call it as hypoeutectoid, and I have marked right side point, that we call it as hypereutectoid. Hypoeutectoid means it is the composition between 0.02 percentage to 0.76 percentage. So, this is 0.76 percentage, that is left of the eutectoid, we call it as hypoeutectoid. Similarly, hypereutectoid means it is the composition between 0.76 up to 2 percentage. Here we have pro-eutectoid, cementite and pearlite are formed. Here we have ferrite and pearlite composition. So, overall summary from the iron and iron carbon equilibrium diagram, especially this three invariant reaction is up to 2 percentage we call it as steel, from 2 percentage to 6.67 percentage we call it as cast iron. Beyond 6.6 percentage there is no significant use. 3 reactions occurred and the 3 reactions are represented here. First one we call it as eutectic, eutectoid and peritectic. The liquid is converted into 2 solid, solid is converted into 2 solid of different phases, and liquid plus solid is converted into a solid, we call it as peritectoid. The reaction, schematic reaction is represented here, and their exact percentage, the percentage of carbon content and the corresponding temperature are represented here. So, that is all about the iron and iron carbon equilibrium diagram. Thank you.